Okay, so this is going to be a video that goes through some important aspects of experiments 10 and 11. So a brief overview first is that experiment 10 is going to be used to create a standard curve for iodide, so I minus. So it's going to be analogous to experiment 2 that we did earlier this semester, where we're going to have a standard curve of absorbance versus concentration of I minus in molarity. So that's going to be the point of experiment 10. So I'll be going through some details of that next. Then from experiment 11, we are going to use the standard curve that we created, and essentially the standard curve, the equation from the standard curve, just like we did in experiment 3, to determine the concentration of I minus at equilibrium. And from that, overall, we're trying to figure out the KSP for PbI2 solid. So that's an overview. So now I'm going to go ahead and focus on experiment 10, some stuff about the procedure that's very important, as well then as experiment 11. So I'll go through some details from both of those. 11, starting with experiment 10, a few things I want to say about experiment 10 is you need to read the bottles carefully. So in experiment 10, you're going to be using 0.2 molar potassium nitrate, and that's our bigger bottle here. So you're going to be pipetting this. It's your dilution agent. Do not pipette from the bottle. You're going to pour this into a beaker, and it tells you about how much you need, about 50 mils. You also are going to need your 0.030 molar potassium iodide. So what we are doing in this lab is getting a standard curve of iodide. So this is our source of iodide, and everything is made in 0.2 molar KNO3. Just kind of ignore that. That's your diluting agent. So instead of just making potassium iodide in water, it was made with a solution of potassium nitrate. So people get caught up in that. Don't worry about that. It's just your diluting agent. So we have this solution. See how it's blue? So you'll pour some of this into a beaker. And then you're going to make a stock solution. Label your beakers with tape. Then you're going to make a stock solution in a new beaker that's labeled with tape by mixing in graduated cylinders these solutions. So you have them in beakers that are labeled, you pour the amounts that you need in your graduated cylinders, and you will get your stock solution. So that is going to be your first part, is making a stock solution, and you need to know the concentration of that stock solution. So before you come to class, and you should do this on OWL, you need to calculate that. So let me show you where this is in the lab. Here's experiment 10. So these are the ones I was showing you. Okay, so these are what you were mixing. You're putting them in beakers that you label. So label the beakers. And now you're making your stock solution by mixing 10 mils of the 0.030 molar Ki in 0.2 molar potassium nitrate. So again, that 0.2 molar, that is used as our diluting agent to make the solution. And then you're going to use 20 mils of 0.2 molar KNO3 in a beaker. So you need to calculate the concentration of the Ki, which is the concentration essentially of I minus. So you should have done that in OWL, but we want the Ki. So we know the initial concentration of Ki, the amount we use, and then we're mixing 10 mils and 20 mils. We have 30 mils total. So that's your first part, that stock solution. I had people totally skip that step last year. Don't skip that step. So you have a beaker of your stock solution, and then you're going to prepare your standard solutions as described in this table, which make sure your pre-lab contains how to make those solutions. Don't just tell me make 5 solutions. How do I make those 5 solutions? So you're using your stock solution and then the potassium nitrate that you have poured into a labeled beaker. Okay, so now still on step 2, you're going to prepare 5 standard solutions of iodide, I minus, with known molarities, because you can calculate those molarities, which you need to do before you come to the lab, described by the table below. So solution 0, so you have your stock solution. Your stock solution is you have 30 mils of it in a beaker. You're going to take 0 mils of the stock solution for your first tube 0, which is going to be your blank. and you're going to take 10 mils of potassium nitrate. So you still have some potassium nitrate labeled. So you want to make sure you have your potassium nitrate. You poured that at the beginning, you labeled it. So you're going to need a pipette that you need to condition. So this is a 10 mil pipette. So I'm not sure if we can see this, but a few things. We look at the top, it's got 2 lines and it says blowout. That means if I want to get 10 mils, I'm going to take it all the way up to the 0 line and I'm going to blow it all out. I'm not going to just let gravity drain it like we've done in the past with other pipettes. It's blowout. So I'm going to use the pipette filler, which you used in your titration lab. I'm going to condition this first. So I'm going to condition it with the potassium nitrate. So that means rinse it a few times, potassium nitrate, put that in your waste container. And then I need 10 mils of it. So I'm going to go up to the 0 line. And then I'm going to blow it out so I can actually use this. I can push all of the 10 mils into my test tube 0. Then your next test tube 1, so we're still going to be doing the potassium nitrate that you have in a beaker. You need 2 mils of it. So if I go up to the 0, that would be 10. So if I want 2, 10 minus 8 is 2. So I'm going to go to the 8 line. So bottom of the meniscus at that 8. So fill it up to the 8, blow it all out, push it all out into test tube 1. So on and so forth. Test tube 2, you need 4 mils. Test tube 3, you need 6 mils. Test tube 4, 8 mils. Test tube 5, 9 mils. So you do all your potassium nitrate first. Then using the same pipette, you're going to need to condition the pipette with the stock solution. So you have your beaker of your stock solution that you just prepared. It's labeled stock solution. You're going to condition it. All right, so you're going to condition this with the stock solution, pour it into the waste container, and then you'll use this pipette for your test tubes 0 through 5. Test tube 0 has none of the stock solution. Test tube 1 has 8 mils. So we'd fill it up to the 2 and then blow it all out, so on and so forth. So that will finish step 2. So step 2, you make your stock solution, and then you'll have 5 test tubes for the next part. So what we're trying to do here is make a standard curve. So our whole goal here is to get a standard curve. So you are going to, as I said, prepare these solutions, and you need to know the concentrations of those solutions before you come to lab. So you need to know the concentration of the I- in all those solutions before you come in. In fact, I'm going to check that this is filled out before you come in, before you start. You cannot start the lab if you don't have this. So we're doing the concentration of I- in those 5 tubes. So here you're going to show, so I want to see this. This should be filled in, how you calculated the stock solution concentration and how you calculated I- in tube 2. So you should have those things done. This whole thing here that I circled should be filled out, as well as these 2. If you do not have those done, you will not be able to do lab next week. So you have to have those done. And of course, they are M1 V1 equals M2 V2 calculations, all of them, dilution calculations. Okay, so when you make these tubes, so you're going to have, actually this says tubes 1' through 5'. Well, here we have tube 0 is just our blank. So it has a 0 molar concentration of Ki because it contains 0 of the Ki stock solution. So that's just your blank for your spectroscopy. But when you make these 5 tubes, you're actually going to have, so here's tubes, I'm going to do tubes 1 through 5. So tubes 1 through 5, and then tube 0, of course, also is the blank, but 1 through 5 are going to be our important ones. So you have 5 tubes, and they are going to be clear and colorless. So we want to do absorption spectroscopy that we've talked about before. We did in experiment 2 and 3 at the beginning of the semester. So we need a colored solution. So absorbance spectroscopy only works with a colored solution. So we actually are going to oxidize the I- to I2, which is brown. And that's going to allow us to do absorbance spectroscopy. So we have our tubes 1 through 5. You're going to calculate the concentration of I- in those tubes. So again, you need to do that before you come to class. And now step 3, which says be very careful. This is where several students make mistakes. We are going to make tubes 1' through 5', which oxidize the I minus to I2, which is a brown color. So reading the instructions, you're taking 3 mils of each standard solution, 0 through 5. So you'll also do this with 0. I'm just explaining it for 1 here, tube 1. So you're taking 3 mils of this into a new tube. So 3.00 mils, pipetting. So condition your pipette with a little tiny bit of solution 1. So rinse it with solution 1. Just a little bit. You have 10 mils of it. So you can do a couple rinsings of your pipette. And then you put 3 mils of it in test tube 1. And you also, so test tube 1 prime. So this is going to be test tube 1 prime. And you're going to add 3 mils of 0.02 molar potassium nitrite. So that, if you hopefully can see me here, is red. Potassium nitrite, not potassium nitrate, potassium nitrite. It's marked with red. So if you want to make a note of that, I'm going to write it in red here. So you are also going to add 3.00 mils potassium nitrite. So make sure you condition the pipette with the potassium nitrite. So pour this into a beaker. Don't stick your pipette in here. Condition it. You're going to add 3 mils of this. And then we do a redox reaction that takes place in acid. So we need a couple drops of 6 molar HCl. So we need 2 drops, 6 molar HCl. And you're going to do that through all of your test tubes. So 0 through 5. And so you'll have 5 new test tubes labeled. You can write on your test tubes with a grease pencil, 1 prime, 0 prime, 1 prime, 2 prime, 3 prime. So you're going to have all of those labeled, and you should see that color is going to develop. So you'll wait 10 minutes for the color to develop. So you should get a brownish color. So I'm going to pick brown here, and I'm going to color it in. Oh, do I even have brown? Maybe this is a good brown color. Maybe it's a brownish orange. So I have a brownish color. So all your prime test tubes now should have a brownish color. So theoretically, we have I2 in our test tube. We need I minus concentration. So we could do stoichiometric calculations to convert I minus concentration to I2. But in experiment 11, we need I minus. So then we'd have to go backwards. We'd be doing 2 extra steps. We do steps to go from I minus to I2, and then we do steps to go I2 to I minus. So it's kind of going in circles. So we're just going to use concentration of I minus that we calculate for our standard curve. So the standard curve you're going to create in Log or Pro, following the instructions very carefully, all the instructions are written out, is you're going to have your absorption, which is unitless. You're going to have concentration of I minus in molar. So again, I'm not converting to I2 because I just have to go in circular calculations. So we're going to have concentration of I minus. So we should see a straight line that has an intercept close to 0. It doesn't need to. And so from Log or Pro, you will write down your slope and your y-intercept. So you'll need your slope value from Log or Pro and your y-intercept. Don't ignore the y-intercept. So you want to make sure you have all of that written down. So going to here, you'll have your slope and y-intercept, which will give you your line of best fit from the Beer's law plot or the standard curve. So that's what you'll need at the end of experiment 10. So before you come into lab, you need the stuff in red. In lab, you will get this. Okay. So again, follow the instructions very carefully on how to get your standard curve. So everything's written in there very, very carefully. So you'll have your slope and your y-intercept, and then you can write your line of best fit. So that's for the first part of experiment 10. Part B is to now make some more solutions, which are going to be our equilibrium solutions. So our whole thing is we want to figure out KSP. So experiment 11 is to determine the KSP for lead iodide. So now we need to make those solutions. So you're going to part B, make some more solutions. Again, reading carefully the bottles. So you'll need 25 mils of lead nitrate solution. So you'll see this as yellow. So you'll want to make sure you have that in a beaker labeled. And again, the diluting agent is potassium nitrate. Okay, and then you're also going to need some of the Ki again, which is the blue. So this is for part B. So reading carefully. So you'll need some more of this. And then you'll need some more potassium nitrate. So you have some beakers already that have, so label all your beakers and you can pour more in to make your solutions for part B. So here we're going to get our equilibrium solutions A through D. And so you're going to prepare those and you're going to put them in, not test tubes, actually, let's do centrifuge tubes, because then you can cap them and vortex mix them. And you can set those aside because we're going to use them as an experiment 11. So while you're waiting for 10 minutes up here, right, for the color to develop, so maybe you can wait 10 to 20 minutes, well, maybe you move on to step B and you prepare these. So that would be a good idea. So again, using your pipettes as I described, conditioning pipettes, making these, make sure you label them in your centrifuge tubes A through D. And then I'm going to talk about experiment 11 next. Okay, so as I stated at the beginning, experiment 11 is to determine a KSP for PbI2. So what we are going to do is let's first write out the reaction that this refers to. So as we discussed in lecture, our PbI2 solid is on the left. We have our ions on the right. So from this, our KSP expression is that our KSP is equal to the concentration of lead at equilibrium times the concentration of I minus at equilibrium squared. So in experiment 10, you prepared some equilibrium tubes. And what you did is you mixed together lead and iodide solutions, different amounts, so different initial amounts of each of those. And you're going to see this solid form. This solid is going to be a yellow solid. So when we think about our ice table here, we are actually starting with some initial amount concentration of lead 2+ that you'll need to calculate and some amount of I- that you'll need to calculate. We're mixing them together. And what we're going to do is we are going to mix these together. And again, like I said, you're going to see the precipitate form. So these are going to be minus then S minus 2S for iodide. We're using those up to form the precipitate. So we have some number minus S, some number minus 2S. And you're going to actually take your, so you're going to have this tube that you put in lead solution, and the lead solution is in this bottle that has yellow tape. So there's a table that shows you how much to put in each of your tubes that actually you prepared in experiment 10. And you're putting in this, you're putting in your potassium iodide solution. So you're mixing both of those together and you're going to get a yellow precipitate and we're going to centrifuge it. So we're going to centrifuge it. This is our PbI2 solid that forms. And the solution that we have here, this is actually our saturated solution. It has as much of the PbI2 solid that will dissolve in it. So we are going to filter out the potassium iodide. We want to get rid of it and we want to have our saturated solution because our saturated solution is our solution at equilibrium. So to do that, you are going to centrifuge it, and then to separate it fully is you're going to grab a little piece of cotton and ball it up, and you're going to get a little syringe, and you're going to stick this on the bottom, probably using a glass stirring rod to stick the cotton over the opening in the bottom. And you're going to pour your solution from your tube into here. And you're going to put this in a new tube. So you're going to have a tube that you're going to squeeze the solution in. So we need to filter it. So you're going to filter it with that syringe system. And once you filter it, Then in your tube, you're just going to have your saturated solution. You're getting rid of that solid. So this is our equilibrium system. So let's call this tube A. You have tubes A, B, C, etc. So that tube A started out with some number of lead in it, some number concentration for iodide, some of it reacts away. So at equilibrium, you have some number minus S, some number minus 2S. Well, we need a way to figure out the S value, and that's where our, like what we did in experiment 10 comes in, where we are going to take out 3 mils of our solution, our saturated solution from tube A. We're going to put it in a new tube that we're going to call A prime. So it should seem familiar, like experiment 10. Then we're going to put in our 3 mils. So this is 3 mils of A. We're going to put in 3 mils of the potassium nitrite. So that's with the red tape. So 3 mils KNO2. Careful, careful, careful. KNO2. 2 drops HCl, just like in experiment 10. And so then we're going to get a brownish solution. So I don't really have a brown color, but we're going to get a brownish solution here. So it should, the color should develop. So then we measure the absorbance. So we measure the absorbance. And if we have absorbance, we go back to our graph, which has absorbance on the y-axis. So this is from experiment 10. Has concentration of I minus in molarity on the x-axis. So you have some equation of y equals some number for the slope, x plus some number for the y-intercept. So we can plug in the absorbance, which is y. We can solve for x, which is the concentration of I minus at equilibrium, which gives us that I minus at equilibrium is equal to some number, the initial concentration minus 2S. So you will have your I minus at equilibrium from your solving from your equation, your line of best fit from experiment 10. You have this value, so each tube has a different initial amount. So then you can solve for S. If you have S, then you can solve for your equilibrium amount of lead, which then you can solve for your KSP. So very analogous to experiments 2 and 3. We are using our standard curve from experiment 10 to solve for I minus at equilibrium. That's going to allow us to solve for S, which will allow us to solve for the equilibrium concentration of lead. Once we have that, we can solve for KSP. So each tube has you have to calculate these amounts that we mix together. So from the table in the lab, your M1V1 equals M2V2 will give you your initial amounts of lead and iodide. So we have, I believe, 4 tubes, A, B, C, and D. You'll calculate 4 KSPs. Theoretically, that should be a constant because if we're at a constant temperature, the lab temperature does vary. So we'll see how that goes. But theoretically, you should get a very similar value for all of the tubes.